So hello everyone. Welcome to today's Water Cooler Chat, where we talk about all things Livepeer, whether it's delegating, broadcasting, orchestrating, transcoding, or AI integrations. We are here to ask questions and get answers. So we do have an agenda item ahead of us today. Today we have a Q&A session with Yondon, one of the co-founders of Livepeer. We're going to be talking about AI compute integration and the roadmap for the compute SPE that's coming about. So, what I'll start with is Yondon. For those of you that are new and never met Yondon, why don't you give us an introduction into who you are, and for those that are watching the recording and who are new into this community, who you are, what you do, and yeah, let's start off with what you're doing with Livepeer currently.
Sure. Thanks for the intro. So I'll keep it short. And as was already mentioned, my name's Yondon, and I am one of the co-founders of the Livepeer project. And previously, I led a lot of the engineering and research efforts within Livepeer Inc., the company. And these days, and most recently, I've been more involved in the project on kind of like core contribution basis. And this AI video SPE project is something that I've been spearheading the technical development of in the past month or so since the idea first came about towards the end of last year. And in the past couple of weeks have just been spending time mainly doing initially some technical prototyping and research in order to get a better understanding of what it would take to integrate some of these AI inference tasks, developing a tighter scope for the work that we're doing, since there's a bigger picture version of the AI video inference workloads that can be supported on Livepeer. But of course, we want to take an iterative approach. So a lot of the work has been just trying to build a better mental model of what makes sense to start with, what the right path is, and what's a practical way to start testing and using some of these capabilities on the network sooner rather than later. And since then, I shared a technical update last week with some of the research results for the more technically inclined, but since then have moved on to start actually developing pieces of the software that would be required to support this sub-network concept that has been talked about previously, where we could start running some of these AI video capabilities. And that's the latest. So that's the current area of focus.
Yeah, that's excellent. That's a really good introduction and overview. I'd like to start off with the first part. You mentioned research, and in your technical update here, you talk about these AI jobs, right? This text to image, image to image, image to video, and video to video upscaling. Do you want to tell us a little bit about the research you've done, what you found, what's possible, and what some of the challenges are with these first kind of job types you're looking at?
Yeah, sure. So the one might wonder why those particular job types, right? So you rattled off text to image to image, and image to video, as well as upscaling. And the reason for thinking about those group of capabilities together, even though we likely won't develop all of them simultaneously and all at once, but the reason that it felt like it made sense to talk about them together was that it feels like all of those capabilities are complements to each other when thinking about for an end developer or even an end user that might be using an application that leverages these capabilities. It felt like for that end user and that developer building for that user, these capabilities would likely be used together in a cohesive workflow as opposed to just one-off capability. So just supporting image to video, for example, or just supporting text to image. Because the original intention was to test the waters with generative video specifically, the question was, well, what would a developer and what would a end user even want to be able to do when it comes to generative video. And I took a this is by no means a comprehensive survey, but from looking around, especially at some of these open source communities that have been playing with the stable video diffusion model dropped by Stability back at the end of the last year, it definitely seemed that there was a lot of chaining of capabilities happening. So what was cool about the stable diffusion model is that give it an image, and then you're able to generate some motion that could be realistic for that image to end up with a 2 to 3 second video clip. But there's a question of where do you get that image from, right? So that's where the text to image and image to image stuff comes from. We've seen a lot of the open source communities chain together different models, so they might use the one of the variants of the stable image diffusion models in order to generate an image given a starting prompt, and then they will then pass that image into the video model in order to get additional frames for that image. So what we've seen in these open source communities is that it's less about just running a single model, and it's more about, okay, how can we take the outputs of one model and then pass them as inputs into another model? So hence the inclusion of both image generation and video generation in the scope of the AI video SPE. And then lastly, it's worth mentioning that in order to get higher quality outputs, we've also seen some other video related techniques being used in order to create clips that can be more shareable on social media or more shareable on Discord. You want the video to look smoother or higher resolution. And for that, we've seen open source communities dabble with taking the output of a video diffusion model and then upscaling it to a higher resolution. Or we've seen the output of a video diffusion model being passed to a frame interpolation model. For those that are not familiar with frame interpolation, it's basically taking the existing frames of a video and then trying to predict what makes sense to insert in between those frames so that you can get smoother playback on the other end. So those are existing techniques that they've been around in their own right outside of pure generation with stable video diffusion. But similar to what I mentioned with image generation, we see people taking advantage of the fact that these models already exist and then they're chaining them together. So they take the output of video diffusion and then use that as an input into some of these enhancement tools. So I mention all of that because that was definitely part of the motivation of thinking about the initial job types where they feel like complements. And in order to make sure that an application developer or an end user that wants to leverage these capabilities can actually get high quality outputs, it felt like it made sense to capture all of that in the initial scope. So I'll pause there. Hopefully that starts to answer your question, but happy to elaborate further.
Yeah, definitely. I wrote down a number of questions and this note of this model to model of outputs putting into using one model to use the outputs of that model to put into the inputs of another model, which I find fascinating. So I want to dive a little deeper into that. What models are you working on? Are you starting with an initial set just for a starting point? Are you experimenting with lots of models? And the Livepeer integration, are you planning to have it be modular to support many, or is that too cumbersome and you're just starting with a great use case to start out with? Can you talk a little bit about the models?
Yeah, so I'll try to cover both of those. So for testing, I've mainly been focused on a smaller number of models because the reality is that there's a lot, so it would be a pretty time-consuming process to try to go through each and every one of them. But the good news is that there's a lot of value in just focusing on the most popular ones. So, for example, video is easy because there is basically the de facto video generation or video diffusion model right now is Stable Video Diffusion from Stability AI. So on the image to video front, that's basically the only model that I've been testing with. On the image generation front, there's a lot more because there have been numerous iterations of the stable image diffusion model released by Stability. But for testing purposes, I've mainly been using this model called the SD Turbo model. This is basically a more recent version of stable image diffusion released by Stability towards the end of last year that is much faster but slightly lower quality than the other previous models. So I've mainly been using that for image generation. And on the frame interpolation side, the model that I've been using there is called Film, which was a model created by Google, I think a couple years ago. The main reason I decided to test with that was actually because Stability AI, for their hosted API, they also use Film under the hood in order to add additional frames to their video. So it felt like it made sense to just use that as a starting point. And lastly, for upscaling, I haven't done as much work here outside of some light testing. This is something that I expect that will get a little bit more love and attention a little bit later on. But for upscaling, what I've tested with is this model called ESRGAN. And for upscaling, to my knowledge at the very least, and as anyone here that knows otherwise can feel free to correct me if I'm wrong, ESRGAN is basically, to my understanding, the most popular open source AI upscaling model and is used pretty extensively all over the place. So if that's the case, that makes things a little bit easier there. So have really just only played around with that one. So that's on the testing side. I can talk about kind of the thinking around what models to support as development proceeds. But any immediate questions or comments before I move forward to that?
Yeah, what I'd like to do is if you do have questions or comments, please leave them in the comment section if you want to write them, or if you have a thought, write them down. And because I know that it's easy to listen, but not to remember, come back to this topic. So please write down your question. I'll also open it up now if anyone wants to jump in on what they just heard. Please feel free to jump in right now. And like I said, feel free to just jot down your questions, so we can circle back to them at the end of the conversation. Did you want to continue on with that trail of thought, Yondon?
Sure. So I think the second part of your question was about the thinking of what models to support
Mm-hmm.
as we can start using some of these capabilities on the network. And the current thinking is to start off simple. So in the short term, what I imagine is that the models that can be used, I think it makes sense to keep scope more manageable, to start off with a specific predetermined set of models. So the criteria for deciding which models go here, I think, would be twofold. One, choosing the most popular ones for the capabilities that we're starting with. So, for example, for video diffusion, if stable video diffusion continues to be the only model supported there, that makes that choice easy. And then on the image generation, choosing one of the base models that are just more popular and have a good trade-off between speed and quality. So that's one criteria. And then the second criteria is, of course, a big part of this AI video SPE is also working with Quan and CJ as they work through their consumer interface ideas. So another criteria here is making sure that whichever predetermined models are supported actually can serve the needs and requirements of that consumer interface. So those would be the two main criteria I would see for determining what makes it into that like restricted set of models initially. And then beyond that, I do think in the medium term and the long term, it could be really interesting to have more flexible support for bringing your own model or being able to give developers easier access to having specific models that might be available on some registry online, have those be run by orchestrators on the network. But I think there are additional challenges that would need to be addressed there, including uh, like how can you trust that the data that you're downloading as an orchestrator is actually something that's safe for you to run. So that's just like one example of not necessarily insurmountable, but just something that requires additional design and thought. So don't think it makes sense to try to solve all of those things immediately, but worth making note that that would be something cool and interesting to explore. But I think it makes more sense to see if the network can really validate like the usefulness of these capabilities with an initial set of models first.
Definitely. So speaking of that, in this case, what it sounds like is rather than trying to build a big modular ecosystem where we're not sure, which takes a lot of time and energy, we're gonna narrow down to something specific, a specific use case, get a specific model working for that use case, and come up with a valuable proposition for a working idea. Is that kind of the initial plan behind this?
So yes, I think so. So I think that is a big reason. I think that is a big reason for being specific. Um, I do think it's also worth highlighting that um, I think by deploying and focusing on a smaller set of models first, can yield many useful learnings for the community and the network around a number of things, including what does it take for orchestrator operators to serve these models efficiently? Because this is a new type of job, right? And this is going to be new territory for a lot of members of the community, and there's going to be a lot to learn for everyone. And I think development is obviously important, but there's going to be a lot of operational learnings. So I think starting with a specific set of models might yield a lot of useful learnings that then could help the community and the network participants generalize so that the framework that everyone comes up with actually is a useful one that is informed by kind of like initial real world deployment. So that's one thing I think could be useful from starting specific. And then another thing I think could be useful is that at the end of the day, I think one of the big reasons for like having this milestone approach for the AI video SPE is uh, proving that some of these open market forces that everyone believes the Livepeer network can enable around the utilization of these GPU resources for efficiently processing video. um, I think the first milestone is like let's see if even forget about like all possible AI video job types in the world. Let's see if we can validate and show that even for a smaller set of jobs that you can really kind of push the price down while still offering really efficient performance for the end user. So I would add those 2 points as well around the motivation for starting specific.
Very good. Yeah, and it sounds like as for building a prototype or some sort of app user facing app, that'll kind of evolve as time goes on. But I want to jump into next more requirements of the network for this type of work. Um, the first one is what is more difficult in terms of the work you're doing. You have kind of like text to image and then image to video, and I guess there's a couple in between there. But what's more difficult? What's more compute heavy, or also what's harder to build out when it comes to these type of kind of stages in this SPE?
Do you just to clarify, do you mean from a development standpoint, or are you also thinking from a kind of like what's harder to run on like hardware and infrastructure.
Let's start from a development, and then I've got more questions about the hardware and stuff. So let's go with the development side of the amount of effort needed to go from text to image and then image to video.
So going from text to image to video, the the amount of effort there is actually not the amount of well, actually I'll start from the first two, text to image to image, because that's a lot easier to explain. But for um those two actually aren't too difficult to integrate. Luckily, thanks to a lot of the great open source work that has happened just in open source AI generally. So for text to image and image to image, and also image to video, which I'll talk about a little bit more momentarily. But for text to image and image to image, we're making heavy use of at least at the moment, the Hugging Face diffusers library, which at the moment is the most popular library for running these so-called diffusion models. So both stable image diffusion and stable video diffusion are what in the open source AI community are referred to as either diffusion models or latent diffusion models. So for text to image and image to image, it's just a matter of kind of like a lot of the code that has been written thus far is making sure that figuring out the right way for an orchestrator or a Go Livepeer node, which is written in Go, to interface with an application that's written in Python and PyTorch and the Hugging Face diffusers library so that the diffusers library code can be run to execute text to image and image to image. So for that, it's really just a lot of like integration code, and it was like figuring out the right way to glue that stuff together. Uh, then image to video, also using the diffusers library. That one, the running the model itself is a little. Running the model itself is also like fairly straightforward with using the diffusers library. Some of the tricky things that we're going through right now is kind of also integrating that with the Livepeer stack, because what we want to be able to do is efficiently take the output of that video generation, which is actually not an encoded video. It's actually a list of image frames. And we basically want to then encode that into a video that can be passed back to the user. So some of the considerations here are just like efficiently passing that data that's generated by the model back to the part of the GPU so that the GPU can then do the video encoding so that you can get a video out on the other side. So some more considerations there. And then for all of these models, so those are some of the, I think, differences when thinking about text to image, image to image, image to video. But a challenge that we'll need to solve for all of these models and have some thoughts as to how to approach this is they consume a bunch of GPU memory, and you also take a latency hit if you have to constantly load data in and out of GPU memory. So one thing that you could do is just as a request comes in, if you don't have the model loaded in memory yet, you could load it into memory. And then once it's loaded into memory, you can process the request. And then when you don't want to process requests anymore, you can unload that model from memory. The benefit of that is that you get to do more, quote unquote, with a limited amount of GPU memory. The downside, though, is that this increases latency for the end user because you have to wait for the model to load into memory, and then you also potentially have to wait for the model to unload and then reload a different model if a different type of request comes in. So I think that's some of the challenges that I think we'll face when it comes to development that isn't specific to any one of these models, but is we'll end up needing to develop a framework so that there are like reasonable options for operators to do when it comes to that issue. So yeah, I'll pause there because I know that you wanted to talk about hardware as well, but
That's a
I'll use that as a stopping point.
that's a perfect segue into the next question, which is, you've the development side. It sounds like there's some good libraries, and it's a lot of piecing things together and getting a nice flow and using what's out there. But now we have the hardware side, which is, the Livepeer network is the global distribution of mostly consumer grade GPUs. What are the hardware requirements? Are we going to see things like the need for A100s, professional grade stuff, or can we be running these models on our 7-year-old 1080s that we can dust off? What kind of what do you kind of predict in this type of requirement?
Yeah, so I can comment on this based on what I've seen thus far, and the good news is that there are some existing resources that, even though like we're still in the process of kind of learning about all of these workloads ourselves, that folks that are interested can already check out. So there's this good resource that I just dropped in the chat. It's this site called gpus.llm-utils, and it has this subpage about GPUs for running Stable Diffusion. This was created back in July 2023, so it's been a little bit. And it's also, I believe, specific to the latest stable image diffusion models and is not incorporating any testing done with stable video diffusion. But from what I've glanced at it and from the testing I've done myself, it seems pretty accurate. But I think from taking a look at this table, this should give you an idea of the relative cost and speed comparisons that one might see for different GPUs when running these types of generative models. So I think what you'll see here is that basically the RTX 4090 offers the best like speed for money ratio. That doesn't necessarily mean it's capable of the highest throughput, but from a speed to cost standpoint, that's probably like the best option for stable image diffusion. So just dropping that link in here first, if folks want to take a look at that, and then going back to the original question around what we expect people to be able to use, I think if there ends up being, well, actually, what I'll start with is that one, I think on the low end, when we think about these generative models and these diffusion models like image diffusion and video diffusion, I think we'll generally expect there to be much higher hardware requirements, and I suspect it will be a struggle for at least in order to provide low latency inference. It will be a struggle to provide low latency inference with older generations. Um, that being said, some of those older generations still might be useful for kind of lower overhead jobs, maybe some video upscaling jobs. But for the generative models, so like image diffusion and video diffusion, I think the floor for the type of hardware required will increase. But I do think you will be able to run them effectively on consumer grade GPUs. You just will not be able to serve as many concurrent jobs. So I think when it comes to like A100s or H100s, yeah, A100s and H100s are always going to be the best if you want to serve as many jobs as possible. But I think it'll still be possible for higher end consumer GPUs to be able to serve these types of jobs efficiently as well. They just won't be able to serve as many concurrent jobs, but that can be okay. I think there will be room for different hardware types on the network based on the type of operator. So those are just some like initial thoughts, but happy to kind of dive into anything else if anyone's curious.
Right. I'll pause there. We do have some questions in the chat, so we'll jump into those a little bit. Andrew says, does having multiple GPUs instead of only one can help speed up the work? Can the resource be shared for parallel work?
So short answer to this is I don't know right now. I've seen some stuff online about some people experimenting with say like splitting a single inference request, a heavier inference request, distributed amongst many GPUs. I don't know what the status of that is and how feasible it is, but that could be an interesting area of research. But I don't know how feasible it is in the short term.
Right. Well, it's interesting that you mentioned that A100s would be great for mass workloads, and then something like a 4090 might only be able to do the one concurrent job. But then the Livepeer network, I'm thinking just off the cuff here, is that's the beauty of the Livepeer network is we are not a centralized entity where we need A100s to process as many customer requests as possible in one location. We don't need density. We're a distributed network. So, to hand off that one job to a 4090 somewhere is acceptable. And so therefore we could have a much more distributed network where A100s aren't the bottleneck, right?
Yeah, that's a good point. So obviously we'll have to see how this unfolds in practice, but that LLM utils table is interesting because if you look at that for image diffusion, they have this column that says speed relative to the H100 for SD, so for stable image diffusion. H100 being basically the cream of the crop data center GPU that there's massive shortages for right now. And the RTX 4090 on the consumer side is half as fast, so 50% as fast relative to the H100. If you look down, the A100 is 43% as fast as the H100 for stable diffusion. So interestingly, the 4090 is actually, based on this table, going to be faster from a pure like latency standpoint for serving a request than the A100. Although the A100, because it has much more VRAM, is going to be able to serve more requests than the 4090. So I highlight that because just going to Titan Node's point, I think it's good news that some of these consumer GPUs like the 4090 is able to actually offer like fast inference, at least relative to the A100, kind of excluding the H100 for now, since that's going to be hard to acquire for a lot of people. But the RTX 4090 being pretty fast relative to the A100 means that even though it's lower throughput, even though it's lower throughput, that might be okay because of Titan Node's point if many people on the network end up having these types of GPUs, because the workload can be shared amongst people on the network that have these consumer GPUs, even if one individual doesn't have like a massive amount of A100 so that they can concurrently process many of those jobs. So just an interesting data point from taking a look at that table.
Definitely. A couple questions. Mike, do you want to come ask your questions? You could probably ask it better than I can.
No, I was just curious about when you were discussing, the 1070s, the 4090s for running different kinds of compute jobs. I just was curious if the selection or the work execution process that's going to be divvying out the work to, are there going to be capability checks to see, oh, you're running a 4090, you have this much VRAM, you can do the work in 30 seconds versus 3 minutes. I mean, I'm not sure if you're that far along yet or not. I'm just curious because that's definitely sounds like a critical component of this particular work you're working on.
Yeah, so I think what you mentioned is definitely going to be important. So at the highest level, I do think as a part of the selection process, there would need to be, for routing decisions, some concept of understanding a node or an orchestrator's capacity to handle a given request that the broadcaster might send to them. Still unclear right now what the best way to approach that is. It's not immediately clear to me that kind of passing around like hardware information, i.e., like what model that you have, is the right way to do it. Maybe, but maybe having some way to get a sense of like the amount of memory available, or just some metric that can capture the orchestrator's ability to handle the next given request that a broadcaster has. So I think that's still to be determined. I think it'll likely build upon some of the work around capacity management that exists for transcoding, but it also needs to be adapted because the capacity management kind of framework for transcoding right now is very heavily centered around um, transcoding sessions. So like the NVENC and NVDEC sessions available on a NVIDIA GPU. And obviously those are not the only considerations when it comes to AI inference workloads. So we'll likely look to adapt the current framework and see if it can be evolved a bit in order to also take into account these other resources that are important for AI inference, i.e., the amount of VRAM you have available, or maybe GPU utilization as well. So no clear answers yet, but I do think that's the direction that we need to move forward towards.
Yondon, I have another question about the development of this stuff. What languages are you using primarily for the fork or spike of Go Livepeer for doing this generative work?
So mostly a combination of Go for the node software, and then for the actual inference code that is written in Python right now. And the with an asterisk, right, which is it's written in Python, but it's all kind of built on top of the PyTorch and Hugging Face diffuser stack. So my understanding is most of that is offloaded to under the hood to low-level C, as well as the underlying GPU CUDA kernels anyway. But all that happens under the hood. So it's a combination of Go for a lot of the systems programming, so hooking things up together with the node, and then trying to encapsulate everything that is AI inference related into this Python package that contains code for setting up these different inference pipelines.
Definitely.
And yeah, there's a comment in the chat about containers. So that's the other part of the stack right now, which is in order for the Go code to, at the moment, the thinking is that in order for the Go code to communicate with the AI inference engine, so to speak, is by putting all of that inference code into Docker containers that orchestrators can then run. So the Go code would be responsible for helping the orchestrators manage, like bringing up and bringing down the Docker containers, and then the actual code execution for AI inference would happen within those containers.
Lazy Days, I see you've joined us on stage. Do you want to? Does that answer your question? Lazy Days, are you with us? We cannot hear you if you are talking. Hopefully that answers your question.
Oh. No, I didn't actually. Sorry, I just discovered.
There you go. Go ahead. Hello? Well, I can't hear you again, so I don't know. Hopefully that answers your question.
Yeah, we'll catch up. I'm here and get at me, Yondon. Thanks.
Awesome. Okay, Yondon, are you good for about 5 to 10 more minutes?
Sure, I'm good.
Cool. I want to end off on a couple more topics. So we've gone pretty deep in the weeds, which is awesome. I think this is giving people a real insight into the work that's being done and the thought that's being put into this. So let's zoom out a little bit. What prototypes has the SPE built or is aiming to build for for release when some of these what prototypes are you looking to go after?
For prototypes, are you talking about the like core Livepeer software or the kind of consumer interface part of the SPE?
I guess a consumer interface. So what an end user might use this for.
Got it. For that one, unfortunately, Quan and CJ are not here because they would probably be the best people to speak to that as they're spearheading the effort, and we're kind of working together in order to make sure that they have everything they need on the back end. So I would recommend kind of like funneling questions over to them offline if folks are interested. Kind of like the high level summary that I can share is I think they're still very much in like the design phase, but some of the things that they've started to consider, including kind of like video based e-cards and like thinking of like kind of shareable memes as like one interesting category that you can take advantage of some of the initial capabilities of generative video. But once again, this is kind of like in the design phase. So I think I would recommend talking to them to get their latest thinking there.
Very good. Another question I had was how much time are you putting into this? Is this full time for you? Is this part time? What level of effort are you putting in and commitment are you putting into something like this? Is it full time, part time? What's your where are you at?
Yeah, so I am spending most of my time on this right now. So I would consider it a whatever your definition of full time is. I would consider it full time. So yeah, this has been the main thing that I've been working on in the past couple weeks, and it's definitely been a fire hose of interesting new stuff. So yeah, it's taking up most of my time.
Definitely. I guess full time means different things to different people. So I guess the way I would define full time is your full attention effort. Because some people 40 hours a week is a just a norm of some kind, but doesn't mean you're actually doing anything for that 40 hours. So it's more of an effort thing. So you would say you're putting your full effort into this just to get it off the ground. And is it been interesting and challenging for you so far, or is this something that you find difficult, or what's your take on how you approach this?
So I'd say both. I mean, I think it's been interesting because it's also been difficult. And so what's the best way to describe this? I think a lot of so this is still happening, but kind of like as I dove into some of these new areas, I think the nice part was that there are a lot of existing open source resources that one can get started with, and those are really helpful for starting to build a mental model around, okay, what does it mean to run inference on a single GPU? What does it mean to run scale inference on a single GPU? There's a lot of useful resources to get started there. But at the same time, it's been difficult in that a lot of this stuff has been moving really fast. So, but I mean, a lot of people here have spent a bunch of time in crypto, so they're probably used to that type of speed. But I think, yeah, a lot of the technical stack and a lot of like the technical kind of best practices are still very much in flux. So it definitely has been a challenge in just trying to navigate that and trying to make decisions of like what's a practical path forward right now, knowing that a lot could change in the next couple of months, the next year or so. So that's what makes it challenging, but at the same time, I think it's part of the fun and it's part of what makes it interesting as well.
Definitely. John, are you with us? He's in the audience. Yeah. He did ask a question around Oh yeah, John, you're here. Do you want to ask a question?
Sure. Yeah, one of the use cases I've thought about a lot with AI is putting captions to live video. So there's a metadata in M3U8 where we could pass captions. Do you think that's a feasible use case or something we should target? And would that be something that could work on lower end GPU hardware?
So I agree that that could be a useful capability and an interesting use case. I know that there have been a bunch of folks that have experimented with this both in and outside of the Livepeer community already with one of the more popular audio transcription models being OpenAI's Whisper model. So I think that's something that would be useful to take a look at. It's not a part of the initial scope for that like first development milestone for the SPE, but I don't think that means that people shouldn't kind of start experimenting with it and think about like how that could be integrated. In terms of whether that could be handled by lower end hardware, I don't know right now. What I do know about this is that there has been a considerable amount of open source effort in optimizing Whisper specifically so that you could run it on lower end devices. I don't know what the kind of actual properties of those optimized models look like. But I do know there are people that have optimized it so that you can run it on like your MacBook, for example. There's this project called GGML, which is basically kind of like a framework for updating some of these models so that they can run pretty fast, not on a GPU, even on like a medium-sized CPU. So if folks are interested in that, I would recommend taking a look at some of that stuff. I don't know,
Cool.
unfortunately, I can't answer like how feasible it is to run it on lower end hardware right now, but could be interesting to look at.
Awesome. Yeah, thanks. Really informative.
Yeah, John, I like your use case because I want to do it for these water cooler chats where I want to transcribe everything that's being said and then make a generative video that people can watch while listening to the water cooler rather than just like a standalone Discord image. So
Yeah, that'd be pretty cool.
be like a cool first use case for that. I don't know if we could get it going. So cool. Okay, well, what we'll do is we're coming up on time here. Yondon, do you want to end on any notes or comments or anything we haven't covered so far that you'd like to share?
Not at the moment. But yeah, if anyone wants to chat about any of this
Yeah.
stuff further, I think the AI
Before
video
he,
channel will be good.
yeah, before you leave, Yondon, I have a question. I would like to hear your take on it, and maybe also Doug's. So I think that along with the cost-cutting factor, I think the models of AI will be competing. I think models will be the main factor of whether one app will select this service or that service. So maybe providing the models, of course, in the testing, when you're preparing a prototype, when you're testing a prototype and, testing on the blockchain, how much of a cost-cutting factor it will provide. Of course, it's all good and well, but I think the GPUs of Livepeer, of course, they are generic, right? So they can provide any service, they can provide any AI service with any model. So do you think it would be a good idea to constrain ourselves with like this model or that model? Like, isn't it better like to make the base case, bring your own model after the prototype, like directly providing that service as our base case, and providing the model would be like Livepeer Studio maybe. If you don't have a model yourself, we can provide it for you for this extra charge. But please, if you can, bring your own model. Would be the first intuitive base case, I think, because models will be competing rather along with the cost-cutting factors of services, I think. What is your take on this? And maybe if I could hear what Doug is thinking about this.
Sure, I can give like a quick response, and then yeah, if Doug's around, he can share what he thinks as well. But just to clarify, is your question or is what you're getting at that you think it could be more interesting post initial prototype to immediately focus on the bring your own model,
Not also
the generic bring
interesting,
your
but
own model framework?
yeah, not also interesting, but also I think it will be the first thing that Livepeer provides rather than providing a model. Because I wouldn't like to hear this sentence. You know, Livepeer is cheaper, but its videos are not as good compared to GPT's video service, for example. Because Livepeer is as generic as it can be, and it should only be or mostly be remembered with this cost-cutting factor, rather than, you know, Livepeer's, okay, it's cheap, but its video outputs are not as good. Because it's not like transcoding, right? It's very much dependent on the model being used. So maybe we shouldn't constrain ourselves, even from the beginning, with a model, I think.
Yeah, I think you bring up some good points there, and I agree with you that ultimately the quality of the model is going to play the biggest role in how good and how satisfactory the service is. So if the model is bad, then the service is also going to be bad. So I agree with you there. Just to clarify, I think what I covered earlier around starting with a predetermined set of models for this like first milestone, I would think about that as really sequencing. So it's not saying that like the product that I don't know, like Livepeer Studio or like the network goes to market with is this constrained set of models. I think it's best to think about that milestone as let's do the technical validation work that you can actually support a base case set of models, and then learn from that, and then use that to move on towards the next goal after that. So I really think of it as more of a sequencing thing than like that's like the end all be all. So just to clarify there.
Yeah, sure.
Yeah, I'm
but
just gonna step in right here. I do want to end this on time. I do have to go, and I want to respect Jan and Doug's time. So if you, Osman, if you want to just maybe wrap that up in just a few seconds.
No, I'll follow it up on the AI video channel, and I could express myself better in writing. So
okay, sounds
that's
good.
better.
Awesome. Well, thank you everyone for joining, and like I said, Yondon, any last comments or anything to close off with?
No, all set. Can catch up on the channels.
Sounds good. Awesome. Well,
Thanks.
thank you everyone for coming. Thank you for your questions. Thank you for participating in this water cooler chat, where we collectively are trying to build the world's open video infrastructure. Thank you, Yondon, for your time coming out and doing this Q&A session. If you want to watch the recording, please head over to tape.xyz and check it out. With that being said, we will end this water cooler, and we will see you all next week. Cheers.